All right, it's going on page 92 when we're done. Right? Do we all have the yellow in front of us? We're all getting Desmos up through Canvas, right? Yes, working on it. Okay. All right, so after Mr. Passwater decides that he wants to get back to his glory days, he joins a gym and begins a workout program designed to increase his maximum bench press. After 2 weeks, his maximum bench press was 230 pounds. After 9 weeks, his maximum bench press was 270 pounds. So his maximum bench press can be modeled by the function B given by this right here. So remember, in FRQ2, it's not necessarily a log function. It could be log, exponential, linear, quadratic, cubic, anything that we've done except for trigonometric, okay? But it'll flat out tell you what you're supposed to do. B of T is his maximum bench press in pounds after week T, and T is the number of weeks since he began the workout program. So here's the little tip. So this is how it's split up so that we can make sure and make sense of all these little pieces. The first one is that when you're asked this, which you will definitely be asked something exactly like this, write 2 equations that can be used to find the values of A and B. This flat out says write out 2 coordinates from the given information, and time is almost always the input. So go ahead right here, and I want you to write out 2 ordered pairs that you get from this information. Then show your neighbor, make sure y'all agree. Use my handy dandy collar over here. All right, check with your neighbors. Neighbor. Okay, we all have ordered pairs. Vanessa, not here. All right. Camden, give me 1 ordered pair. 2, 230. Y'all agree with that one? All righty. Then Dayanara, give me another one. 9, 270. We agree with those? Yes? Okay, what some of you may need to do, not necessarily everybody, I mean, it wouldn't hurt anybody, but you may also want to write out T, B of T, and we'll talk about why here in just a minute. Again, it's not that everybody necessarily needs that, but you'll find out in just a second whether or not I think you're one of the ones that needs that. All right, so now let's actually do the first part of A. We're going to take this. Are they asking us to solve for anything? No. We are just supposed to write 2 equations, correct? All right, so write 2 equations based on what they have given you. You can consult with your neighbor. Help each other out if we're not sure what to do. All right. You're on the right track. Okay. 70, can you give me 1 equation? Natural log of 2. Y'all agree with that? Yes, thank you, Devaney. All right. Natalie, can you give me another one? Very good. Okay, so some of the weirdness that I have seen, not only today, but on your last test, and I'm not sure if I saw it in here or not, but some of y'all were hesitating to write. I think you were waiting for me. Instead of the 230 and 270, you're putting B of T because that's what you see right here, okay? This should be a very, very easy point for you, okay? We should not be missing this point. If you're confused about what to put in, if I need to solve for A and B, then that can be the only two variables that are left in there. So I'm replacing t and b of t. So if you weren't sure what to put in there, that's what I think maybe you need to write that so you can be like, oh, that's what I'm substituting into what they gave me. You with me on that? We good? That should be an easy point, right? None of us should be missing that point. So the FRQ2 last year was almost identical to this. I mean, you know, with the exception of the prompt and stuff. But the questions are pretty much exactly the same, asking you to do certain things. 58% of people that took the test got this point. It should be 100% of y'all. Don't you agree? We can get that point. Because no matter what the equation is, it's going to ask you something like this, and you should be able to substitute the stuff in and move on. We good? You didn't even have to come up with the points themselves. They gave them to you, or they gave you the information anyway. All right, so now we need to find A and B. And our little tip over here is you can use regression. Not just that you can, you should. Don't try and do it by hand. Use the calculator. This is a calculator question. So we're going to go to Desmos. And then go ahead and put in your information. Put in your two ordered pairs. So then when I hit regression, what kind of regression am I trying to get? What do I choose? Logarithmic. Very good, because it's a logarithm. So I've got this right here. Now, when we have done logarithmic regression, we have, sometimes we manipulate things, right? If I needed log base 2 or log base 10, we might come in here and manipulate this. Or if it was t plus 1, we'd have to manipulate something else. But what they gave me, y equals a plus b times the natural log of x. When I look at this one, that's exactly what this is. I don't need any manipulation, right? So I'm not doing anything weird there. What they gave me right here is a and b. How many ordered pair? I mean, how many decimal places do I write down? 5. Okay, so let's go ahead and write those down. A equals 211.56618. Okay, any questions about that or Desmos on that? I think we kind of got that down, right? We've done that enough. So 36% of the people got that point. Should we get that point? We absolutely should get that point. I think one of the reasons that was so much lower last year was because we didn't have Desmos, and so you kind of had to do some more on the calculator, and then people got confused on when you had to and when you didn't, and then people were trying to do stuff by hand where you shouldn't have been. So I don't think that hopefully that won't be an issue, you know, so far. But we should be able to get those 2 points, yes? Okay. So now let's look at B. B says, use the given data to find the average rate of change. What is average rate of change? Rachel's not here. Casey, what does average rate of change mean? Slope. That's all it is slope. Can y'all do slope? Y'all been doing slope forever? Yes. We're not going to miss the slope question, right? So the average rate of change in Mr. Passwater's maximum bench press in pounds per week from 2 to 9 weeks. I highly suggest you do this every time. And express your answer as a decimal approximation. So let's pause here and talk about that for just a second. Because on your last test, you had a question exactly like this. The numbers worked out nicely to where the slope ended up being 3/4. But it said decimal approximation. Is 3/4 a decimal? No. Answer the question that's being asked in the way that it's being asked. And if you got 3/4, that means you are doing too much by hand. If it is a calculator question, let the calculator do it. Okay? That's super important, and make sure you're answering them correctly. All right, so then here's your average rate of change in function notation. What variable traditionally represents slope? What letter? M, okay? So M equals slope, and I'm going to use that here in just a second, okay? So we're going to write out our slope first in function notation. I'm not going to use F's because I'm not going to be a Melissa, right? What is the name of this function? B. So I'm going to do B of 9 minus B of 2 over 9 minus 2. That's step 1. Make sure those numbers are lined up so that we don't miss something simple like slope. Then we're going to substitute in what we know. What is b of 9? 270 minus b of 2, which is 230. And then leave this 9 over 2, because you know what? On your last test, some of you didn't subtract right when you don't need to. The calculator is going to do it for you. Now, what I'm going to show you, I think I've showed you once, but remember in Desmos, we don't get to tell it to store a number like we can on some calculators, but we can assign stuff. Well, maybe. Okay, there we go. Instead of just putting that in, I'm going to put m equals. I am identifying what this value is going to be. Then I can put in the fraction, 270 minus 230 over 9 minus 2. That's 7. We don't want to do that. You also have to make sure you type in the correct numbers. And then there is my slope. Okay, everybody good with that? We can find slope, right? All right, so let's go ahead and write that down. So this is my answer then. Write down your 5 decimal places. 5.71428. That should be an easy point. Do you agree? So far, these 3 points, out of a total of how many? 6. These 3 points should be pretty simple to get, yes? All right, global average. Well, global mean, and then I was going to ask you what mean means, but average, because I just said it. The global average for FRQ2 was 2.03 last year. So we're already above the average, right? We're above average anyway, right? So you can get these. Remember, you're not always going to get all 6 points or be comfortable with them. That's okay. We're going to get everything we can. We can get 3 points. We are pumped, right? So now this one. This is where things fall off again. Use the average rate of change found in I, this one right here, to estimate Mr. Passwater's maximum bench press in pounds at time t equals 10 weeks. And show the computation that leads to your answer. I think sometimes that's why I'll do too much by hand, because it says show the computations. Showing computations doesn't mean showing all of your work. Showing that this is what I'm putting in my calculator, that counts. That's totally enough. Okay, does that make sense? So let's go here. And I left this on here because, remember I told you, we can write the equation of a line and go that way, but I don't think that that's the best way to do it. I think using this from function notation is the best way for you to make sure that you can just get this answer correct. So I want to find b of 10. I'm going to look right here, and I'm going to replace this first one with whatever I'm looking for, b of 10. Then that's minus b of 2 over, and then make sure you do 10 minus 2 or whatever the numbers are. Don't use these numbers. They have to match this. That's how it works, right? Everybody good so far? All right, so then I'm going to substitute in what I know. I don't know b of 10. I do know b of 2. What was that? 230. And then I really do need to do 10 minus 2, which is 8, but I think we can handle it. If you get into the double-digit numbers, use the calculator so you don't do something ridiculous with subtraction, okay? Not because you're dumb, but because we're human. I am using this slope. This is still a slope. This slope is supposed to equal this slope. That's how I'm using it. So I'm going to set that equal to m. And literally m. So the next part, we don't necessarily have to write, but I think most of you are on board with this, but I don't want to lose anybody. If I want to get b of 10 by itself, I would start by doing what with that 8? Multiplying it. So I'm going to get 8 times m, and then what? What would I do with that 230? Plus 230. And that's going to equal b of 10. Okay. So again, you wouldn't necessarily have to write it. Maybe you want to. Maybe you should. I'm not suggesting that we skip a whole bunch of steps, but if you know what to type in, that's fine. So we come back over here, and then I'm going to do 8 times m. And that only works if you actually identified what m is. And then we're going to add 230. Everybody good with that? Okay. What questions you got? Yes. Okay, that's a good question. So I told you to substitute it in to this one, right? So if I understand your question correctly, is like, do I have to put it into this one or could I put it into that one? Is that what you're asking me? Okay. So think about what would happen. So you totally can, but here's why I don't suggest we do that. First of all, for consistency, but second of all, if I did substitute it in here, so this is my unknown and this is what I know, then I'm going to subtract that to the other side, and then I have a negative over here, and then you have to deal with another negative. You with me? So it really makes it easier on you to do the first one. But you could also put b of 10 right here and make this b of 9. And as long as this is 10 and 9, you're fine with that too. Okay, that's a good question. I was just trying to show you how to kind of be consistent, but you would be fine. As long as everything stays lined up and you do the math right, it does not matter. Okay, very good question. Anything else? All right, so what we got here is b of 10, right? So go ahead and write that down, b of 10 in your 5 decimal places, 275.71428. All right, and then I want to know what those units would be. You know, if you'd have told me like, I swear my ID just jumped right out of my pouch, I'd be like, you're so full of it. But I think that's what just happened, isn't it? Helen, what are the units? What do you think? What are we looking for? Maximum bench press, right? But so what are the units on that? Pounds, yeah, you got it, sorry. Just trying. So you can put the word pounds or you can use the units, but, and B units, yes, your output units. Because T is weeks, this is your output. Your input is weeks, your output is pounds, right? Okay. What questions we got? Yes, ma'am. We did not need to, but we don't have to, but let's do that because it's going to be important in just a minute. So this is a rate, right? And we made it from a fraction. Yes? So your units should also be a fraction. And when you did this, it was the change in y over the change in x. What are your output units? We just said them. Pounds. Okay, so we can use the word here because it really doesn't matter how you do it as long as you do it correctly. Pounds. And what are my input units? Weeks. So that is pounds per week. Okay, good question. Anything else? Was that a question? Yes, ma'am, go ahead. That's absolutely fine. You can write out the words pounds per week. If you choose to do it like that, so you just set up a fraction and move on, that's fine too. It's possible you do something where your units don't make sense to you. Don't overthink it. I haven't really seen that happen in here, but it's going to happen to you a lot in calculus. Well, you'd be like, this doesn't even make any sense. Don't worry about it. Put output over input and move on. Okay? Anything else? Good questions. All right. So this next part, I'm just going to go through with you quickly because this is kind of an alternate to part 2. I don't think this is how it will be asked. I think it'll be asked the other way, and I'd rather spend some more time on other things. So we'll just write this out and talk about it quickly and move on. So this says to interpret the meaning of your answer from part 1 in the context of the problem. And here's a little sentence stem for you. And again, my words never have to be your words. So I don't always love giving you things like this because then I think you feel like it has to be very stringent. It's okay to say it in your own way as long as you say what needs to be said. But I'm just going to go ahead and follow this. And since in I, when we found the slope, that was our average rate of change. So we have to use the word average. Not necessarily here. I'll tell you where else we could do it after we write it. On average, V, okay, so what are we talking about here? What is our output? That is our pounds, right? So number of pounds, I'll put lbs, Mr. P can bench press. So that's what's changing, right? What? On average, the number of pounds Mr. P can bench press, that's what's changing. Are the number of pounds increasing or decreasing? Increasing, because the slope is positive. So if the slope's positive, we're increasing. If it's negative, we're decreasing. So the number, looks like P can, but number of P can bench press increases by, and then what our slope is, which was 5.71428, and then pounds per week. So if we hadn't already written it on that one, we just wrote it, then we'd have to figure it out here. So that's these units here. Then from T equals 2 to T equals 9 weeks. That's just interpreting slope, which again is something that you've done for a long, long time. The word average is very important in that. So you could have said, and sometimes I feel like we start writing things out, myself included, and I realize I forgot that word. So if I started off with the number of pounds Mr. P can bench press increases, and I can say by an average of 5.7, like you could use the word there. You can mix up your words as long as you're saying the same thing, okay? Any questions at all? We good? All right. I really think it'll be asked the other way though, so I'm not going to focus on that too much. All right, so let's look at this. The average rates of change of B from T equals 9 to T equals P weeks. So we've seen this a few times. Hopefully, the more we see it, the more it'll make sense. Are these average rates of change less than or greater than the average rate of change from T equals 2 to T equals 9? All right, so if we are talking about average rate of change, and it says, not only do I have to explain it, but my explanation should include a reference to the graph. So I'm looking at a graph, and I'm talking about rates of change. What do I need to write down? Fun chart. Thank you very much. So let's write down our fun chart. And I know that some of you have the fun chart in your brain, and you feel like you don't need to write it down. I mean, that's okay, but I think it's better when you see it and you can really just box things and know what's going on. Then I also think you need a little sketch of your graph. It doesn't have to be beautiful. It doesn't have to be much. You don't even have to guess because you can see what's happening here, right? I know pretty much what it looks like, and it's a log. Looks like this, right? Good enough. This would be the slope we just found from 2 to 9. These would be the slopes that are past that, right? Very rough sketch, but just so I understand what the heck is happening. Do you think that these average rates of change are going to be more or less than these average rates of change? Less, okay? And you cannot say less and then show that you found other rates of change and show that they're lower. That's not going to work because it says make a reference to the graph. What can you tell me about this purple function here? It's concave down. And since it's concave down, my rates of change are decreasing. Then we got to put all that in words. We start off by, just like your English teacher taught you, restating some of the question. So we can say, average rates of change of who? Melissa? F? B. That kind of who. Not Mr. B. Average rates of change of B from T equals 9 to T equals P weeks. Okay, I'm getting that straight from that question, right? I just pretty much just wrote this. Okay, and I don't have to worry about P is greater than 9. It's okay. R, did we say there were more or less? Less. Less than, and we don't have to say average rates of change again. We can say less than from T equals 2 to T equals 9 weeks. All right, so that's my answer. They are less. Am I done? No. I have to explain. There's no explanation there, even though I wrote a lot of words. Because, can I say it? No. Who is it? B. Because B is what? Concave down. Is B always concave down? It's a logarithmic function. Is it always concave down? It is, right? Have we had functions that are not always concave down? Yes. So if it's not always, then we have to say concave down where. If it's always, we don't have to put an interval, okay? So that's good. That's something, but that still doesn't tell me, that doesn't directly relate. I have to say what that tells me. That tells me, therefore, the average rates of change are what? Decreasing. And are they always decreasing? When do they decrease? They decrease when my function is what? Concave down. Is my function always concave down? Yes. So then do they always decrease? Yes. So then I don't need another interval. What questions you got? We good so far? All right. So for which t value, now this is, so on here, part C will always ask about some sort of restrictions for our model. It might ask you about how we could or should limit domain or range, which we've seen a couple like that. This is kind of the free-for-all question. It can be asked a lot of different ways. So we haven't seen one that's like this before. So I want you to think about it and talk to your neighbor about it for a second. It says, for which t value, t equals 6 or t equals 19 weeks, should Mr. Passwater have more confidence in when using the model? So think about this. Just because I have some data and it looks linear or it looks quadratic or it looks whatever, does that mean that that model works really for every input I ever use? Not necessarily, right? It might just be good for like a little section of data. So think about what would make more sense, 6 or 19. Talk to your neighbors about it. Fight it out. And why? Not just give me a number. All right, do we all have an idea? Okay, let me see who my lucky volunteer is. Jenny, what do you think? Ugh. Just give me something, hun. They said 6. Why did they say 6? What do you say? You just going to go along just because all the cool kids said 6 or what? Okay. Well, did they give you a reason of why they said 6? Do y'all want to help her out with why you said 6? You going to pass it off to Alanya? Okay. So why would that make him think that the model would give me a better answer at 6 than at 19? Was anybody team 19? Okay. Can anybody give me a different reason why they think 6 is good? He's pointing at you. Exactly. Yes. Okay. So I want to think about this. I mean, there's a lot of different ways we could talk about this, but when I do this, if I figure out where, so if I put x equals 19 here, and I go and look at what this is, well, at 19 weeks, it's 289 pounds. Now, again, I don't know anything about bench pressing, and maybe after 19 weeks, that is reasonable, right? I mean, I guess that's possible. I don't know what his limitations are, but as a logarithmic function, this is going to continue to increase. Do you think his max bench press is going to continue to increase to infinity? No, probably not, right? He's going to hit a limit at some point and maybe start going back downhill or something. You just never know. So even though this might still be accurate, when you really want to trust your model, and here's the good thing, is that if you get asked a question like this, really whatever the problem situation is, the answer is kind of the same all the time, and it's basically what Jaime said. And that is that, so we can say, let's write this out logically, that Mr. P should have more confidence and T equals 6 weeks. And so let me kind of give you the wordy reason why and then what we can actually write. And it is because it's between 2 and 9, because we really only know anything about the rates of change between 2 and 9, because those are only two pieces of data we have. So if it was less than 2 or greater than 9, our models might still work, but it's not going to be as accurate as if it was actually in the information we knew. Does that make sense to you? Okay, so Mr. P should have more confidence in T equals 6 weeks because T equals 6 is within the data interval we know. And then we'll put out what that is. We're going from 2 to 9 weeks. Okay, so it's in between. That's what it is. Okay. What questions we got? We good? Yes?